back to another lesson. Today's learning goal is I can represent the domain and range of quadratic functions. So remember that domain deals with the x values and range deals with the y values. So here it says find the domain and range of this quadratic function. We have these arrows here. Okay, pay attention to those arrows. So that means this goes all the way up, all the way up. And this one also goes all the way to the left, and this one goes, or excuse me, right, and this one goes all the way to the left. So when we have that going on, the domain is all real numbers, negative infinity to infinity. Okay, for the range here, it's going to be the lowest point. The lowest point we can see right here, the minimum is -7. So it's going to go from -7 to infinity, so it's -7 to infinity. Go ahead and try number 4 out on your own. Again, you should have found that the domain is -infinity to infinity, and range should have been -infinity to 3. The domain and range of a quadratic function can be determined from a quadratic equation. The domain of the quadratic equation in standard form will always be all real numbers. Okay. To determine the range, use the steps in the box below and find the domain and range of g of x. So the first thing you have to do is look at the a value to determine whether the function has a maximum or minimum. Remember that a -1 is going to have a maximum because it's opened down, and a positive a will have a minimum because it's opened up. Then we have to find the maximum and minimum of the function by finding the vertex, and we can use the formula x equals -b over 2a to do that. Then we write the inequality using the maximum or minimum. So like this says right here, any quadratic in standard form, if it's not inside a word problem or anything like that, is going to have a domain of all real numbers. What we have to do next is find out if it has a minimum or maximum. Well, this is going to be opened up, so this is going to have a minimum. Okay. So next we can find the vertex. And the vertex, the x value of the vertex is going to be -10 over 2 times 5. Okay. -b over 2a, which gets us -1. So we're going to plug in -1 right here into our equation and see what we get. So 5 times -1 squared plus 10 times -1 plus 3. We do that, we find that this is 5 plus -10 plus 3, which gets us, plus 8, excuse me, plus 8, which gets us a total value of 3. So we have a minimum of 3, so therefore it's going to go from 3 to infinity, including 3. Go ahead and try 5 out on your own. What you should have found was the domain was -infinity to infinity because all standard form quadratics will have that domain. And then if we plug in for -b over 2a, we find that x equals 3 for the vertex. And we plug that in, we find that the minimum, or excuse me, the maximum is -5 because this is open down, so therefore it's -infinity to 5, including 5. Go ahead and try number 6 out on your own. Again, you should have found that the domain was -infinity to infinity, also known as all real numbers. The range should have been -9 to infinity because the vertex has a x value of 3. And if we plug that in, we find that we have a minimum of -9 because we have a positive a value. Number 7 says the table below shows some coordinate points of a quadratic, including the vertex. Here, what is the vertex? Well, we can see that we have a maximum point right here, because here is the very middle of it, right? We can see that it's going to be, on both sides of it, it's going to have lower numbers. So therefore, that's going to be our vertex of -2, 13. Can the range be determined from this set of data? If so, find the range. If not, explain your reasoning. Well, we said that this is going to be a maximum because this right here, 13, is higher than the ones next to it. So it should look something like this. And if this is -2, 13, we're going to have a range of 13 and less. So therefore, yes, the vertex of the point is the point where the function changes from increasing to decreasing. The vertex here is -2, 13. And the range is therefore y is less than or equal to 13.